Hello students, welcome to the chemistry classes. Today we are going to discuss the group 1 elements, general discussions of or general characteristic properties of this group 1 elements. So, the alkali metals shows the regular trend in physical and chemical properties. So, what are alkali metals? The group N elements are called alkali metals. What are the elements present in the group 1? Lithium, sodium, potassium, rubidium, cesium and francium. So, this majority of the properties top to bottom varies regularly, either increases or decreases. So, in this we are discuss some properties of alkali metals, general properties of alkali metals. The first one is electronic configuration. Electronic configuration. All the alkali metals having only one electron present in their valence shell. So, lithium, sodium, potassium, rubidium, cesium and francium. Atomic number 3, 1s2, 2s1. 1s2 is the configuration of helium. Therefore, shortly it is written like this: configuration of helium 2s1. And 1s2, 2s2, 2p6, 3s1. This is a configuration of neon, neon 3s1. So, the potassium configuration of argon 4s1, rubidium configuration of krypton 5s1, configuration of xenon 6s1, configuration of radon 7s1. So, this is the electronic configuration. The longest form of electronic configuration is 1s2, 2s2, 2p6, 3s1 and etc. It can be written according to the periodic rules. I already explained periodic rules. We shortly write electronic configuration as like this: helium 2s1, valence. All look at this electronic configuration, all the elements having only one electron present in the valence shell. So, 2s1, 3s1, 4s1, 5s1, 6s1 and 7s1. This is the first property. The second one is atomic and ionic radii. Atomic and ionic radii. Atomic radii and ionic radii. So, what is atomic radii? The distance between center of the nucleus and outermost orbit of an atom is called atomic radii, and the distance between center of the nucleus and outermost orbit of the ion is called ionic radii. So, we know that top to bottom the size of an atom increases. Top to bottom size of an atom increases because the electrons are enter into new main energy levels. So, the force of attraction between the nucleus and the valence electrons are decreases. So, it leads to reduction in increase in size. Forces of attraction decreases, size of an atom get increases. Top to bottom, as we move from lithium to cesium or francium, size of an atom increases, or atomic radii or ionic radii of atoms increases. This is the one general properties. Ionic means from lithium one of the ion is removed. From the lithium one of the ion is, one electron is removed. That is, it becomes lithium plus, sodium plus, potassium plus. So, I already told you, comparing the size of cation and parent atom. The size of cation is small when comparing with its parent atom. Size of cation is small when comparing with the parent atom. And what is the general variation? Top to bottom ionic radii also decreases. This is a second point. The third point, ionization energy. Ionization energy. What is ionization energy? The amount of energy released required to remove the most loosely bound electron from the isolated atom. In the gaseous state, only one electron present in the valence shell, the atom possesses greater tendency to remove the electron from the valence shell and it exists as the stable configuration. Therefore, the valence shell electron is easily removed because only one electron present in the valence shell. The force of attraction also decreases. Therefore, lesser amount of energy is utilized to remove the valence shell electrons. Therefore, the ionization energy top to bottom ionization energy decreases. Cesium is very much easily remove one electron from their valence shell. With the help of sunlight, it can emit the electrons. Therefore, lesser energy, top to bottom size of an atom increases, force of attraction decreases, ionization energy also decreases. So, this is the next point. And hydration enthalpy. Hydration enthalpy of alkali metal ions decreases with increase in ionic size. Hydration enthalpy. Hydration enthalpies. So, this is based on ionic size. Hydration enthalpy of alkali metals ions decreases with increase the ionic size. Ionic size from lithium to cesium, size of an atom increases or size of an ion increases. When the size of an ion increases, hydration enthalpy decreases. Hydration enthalpy decreases. Simply say top to bottom hydration enthalpy decreases in the case of monovalent ions of alkali metals. And the physical properties, and some physical properties, all the alkali metals are silvery white in color, soft and light metals. Because of the large size, these elements have low density which increases down the group from lithium to cesium. One of the characteristic property of this alkali metal is it imparts a characteristic color. Formation of colored ions. Colored ions formation. It consists of only one electron present in the valence shell. So, when it is these ions are heated, when it is shown into the flame, it absorbs energy from the energy and it goes to the excited state. What is the excited state of electron? The valence shell electron is the ground state. We are heating and it goes to the excited state. This excited state is highly unstable. Excited state is highly unstable and easily returns to the ground state. When it returns to the ground state, it emits some radiation. This radiation coincides the particular region of wavelength of Vijaya region. So, it produces that color. It imparts the particular color when it returns to the ground state. When it returns to the ground state, emits some radiation. The emitted radiation coincides in a particular wavelength region of Vijaya. So, that color is produced. For example, crimson red color, lithium shows crimson red color, sodium yellow color, potassium violet color, rubidium red color and cesium blue color. The lambda value is also given. So, this is determinant on basis of atomic emission or atomic absorption spectroscopic methods. So, color is somewhat important and the formation of color is due to the absorption of energy when it is heated to Bunsen flame. So, it absorbs the energy and goes to the excited state, returns to the ground state, it emits some radiation. This radiation coincides the particular Vijaya region, that color is produced. Then these are some physical properties. These are the very soft metals and easily cut with knife, and sodium is always stored in the kerosene. When it is take it outside, it is easily catch fire. Therefore, it is always stored in kerosene. So, these are the some properties of this alkali metals. So, I conclude this topic. If you have any doubts, you may ask. Thank you.